10.5 Reading Scientific Notation. We have some key vocabulary. The first part is the word scientific notation. So this is a number is written in scientific notation when it is represented as a product of a factor and a power of 10. So, for example, we have 8 and 3/10 times 10 to the negative 7th power. So 8 and 3/10, that is our factor. Ten to the negative 7th is our power of 10. There are two more requirements. The factor must be greater than or equal to 1, and less than 10. So that means that this 8 and 3/10, that value is between 1 and 10. It can equal 1 or be greater, but it cannot equal 10. It has to be less than 10. Okay, then for the power of 10, must have an integer exponent. So that means that our exponent must be a positive or negative whole number. So let's look at our key idea. A number is written in scientific notation bear with me a moment. Having technical difficulties. A number is written in scientific notation when it is represented as the product of a factor and a power of 10. The factor must be greater than or equal to 1 and less than 10. So to have some examples, 3 and 9/10 times 10 to the 6th power, or 6 and 73/100 times 10 to the negative 4th. So let's take some examples by identifying numbers written in scientific notation. Tell whether the number is written in scientific notation and explain. Letter A says 5 and 9/10 times 10 to the 6th power. Well, if I go back up to my definition, it has two requirements. The first is in red. The factor must be greater than or equal to 1 and less than 10. The power of 10 must have an integer exponent. So if we take 5 and 9/10, that is our factor. That is between 1 and 10. So check, we're good with that. Then our exponent of 6 is an integer. So check. Yes, this is written in scientific notation. So I'm going to use the abbreviations of SN from now on to represent scientific notation. Moving on to letter B. 0 and 9/10 is not between 1 and 10. So no, this is not written in scientific notation. So when it says to explain, I'm showing my work by having the 1 is less than or equal to x, which is less than 10, being crossed out. So that can be my explanation. So let's move on to the next key idea. The absolute value of an exponent indicates how many places to move the decimal point. So if the exponent is positive, you're going to move the decimal point to the right. If the exponent is negative, you'll move the decimal point to the left. So one way to try to remember this, if you have a number line, the positive numbers are to the right. And if you have negative numbers, those are to the left. So example 2, writing number in standard form. Write the number in standard form for letter C. 3 and 22/100 times 10 to the negative 4th. Well, this negative 4 means I'm going to move the decimal to the left. And I want to move left 4. So I'm going to write 3 and 22/100 and put it further to the right because I know I'm going to have numbers to the left. So I'm going to move it 1, 2, 3, 4. Here's my new decimal point, and I'm going to put a little arrow indicating that's where I went. But when you don't have numbers, you put in the zeros. I also like to put the 0 out in front of the decimal. Now I can't leave my answer like this, it's too sloppy. So I'm going to rewrite it without the movement marks. All right, for letter D, this is a positive exponent, so we're going to move the decimal right 5. So I'm putting RT for right. Actually, you know what? Let me redo that. Okay, so 7 and 9/10. I'm going to move it 1, 2, 3, 4, 5. I'm going to fill in my zeros. 790,000 will be my final answer. All right, example 3, comparing numbers in scientific notation. So far we've learned if a number is in scientific notation, the factors between 1 and 10 couldn't equal 1, but has to be less than 10. We've learned if it has a positive exponent, you move the decimal to the right. If it has a negative exponent, you move it to the left. So we're going to take all of that knowledge and try it with letter E. So an object with a lesser density than water will float, while an object with a greater density of water will sink. So we're going to use each given density in kilograms per cubic meter to explain what happens when you place a brick and an apple in water. Well, before I even look at this, I want to use just my background knowledge. If I have a bucket of water and I have a brick if I were to drop that brick into the water, just from my knowledge, it's going to sink to the bottom. But I know apples float at the top. So what I'm going to do is find all of the densities in standard form. So 1 and 0 tenths times 10 to the third power. Positive exponent of 3 tells me I move to the right 3. So decimal 1, 2, 3. Put my new decimal to the right. So that's going to be 1,000. For the brick, same idea. 1 and 84 hundredths times 10 to the third. I'm going to do the decimal 1, 2, 3, add in 1 0. 1,840. Okay, well, I can see that the brick is denser than the water, so the brick's going to sink. The brick will sink because it is denser than water. All right, then for the apple, you have 6 and 41 hundredths times 10 to the second. So just like before, I'm going to move my decimal to the right twice. 641. Well, if I compare that to water, I can see that this is less dense, so it will float. The apple will float because it is less dense than water. All right.